So my name is Marty Cochrane. I come from this wonderful island here called Ireland, where we have very interesting weather, as you can see from the slide. I've lived in Norway for 6 years, and I'm currently the Director of Solution Architecture at Arundo. I'm going to cover a few slides, just a bit about me, because I think it gives you the sort of story to what we're talking about today around edge analytics and where that's sort of come in the last few years. So I started my career at this, what I think is quite a beautiful place. It's a big power station in Northern Ireland. It's from the 70s. It's a coal and oil power station. I think most people in the area would prefer to see it burned down, but I quite like it. I think it's quite a cool place. It's a really cool technical challenge. And it probably will burn down sooner or later. But when I was there, what I played with was this. So I apologize, we've just had a talk from a process control engineer. If some of you are data scientists, this is my background as well. So apologies for that. But no, I played with this, right? So what I love doing is I love taking the virtual environment, which is your computer, software, and controlling big machines. It's pretty much every guy's dream, right? Just huge big machines and typing something in your computer and seeing these big machines move, and I can control them and make big loud noises and so on. And this is where my sort of background came from. After that, then, when I moved to Norway, I moved to Europe's biggest renewable energy company. And this is me standing on top of a wind turbine with them, doing the same kind of thing, collecting data, controlling machines, and hopefully doing something more than just standing and looking at the views. Now, that's me in my sort of professional career. This is what I do Monday to Friday. At weekends, I change into quite a different person. Not quite as different as this, thankfully. But as you'll see from our booth today, I spend most weekends, especially in the summer months, racing motorbikes all around Europe. Now, this is very valid for what we're talking about today, because on my motorbike, if you come and see me racing most weekends, you'll also see me in the garage doing this. I collect over 100 sensors from the bike to optimize my performance, to optimize the performance of the bike, and to make sure I don't get any failures in a race, right? So we look at things like oil platforms, right? In Arundo, we work a lot with oil and gas, and what you really don't want to do is have a failure. It's the exact same for me here. It is catastrophic if I have a failure on a Sunday during a race, if it's an engine failure or something. And this is how everything is going. Even in the motorbike racing world, in Formula 1, you'll see things like this. And these are just some of the people that I've helped in the last 2 years do similar things. Norwegian champion, Swedish champion, European champion, and previous world champion. All people that want to sit and look at their data, make sure their bikes aren't failing, make sure that they are optimized, the bikes are optimized, and we do this by collecting data. Surprise, surprise. So, a bit about Arundo. You've heard a bit about us already today. We couldn't really call ourselves a startup anymore. We are a young company. We've been around for just under 3 years. And we're basically a collection of people with very relevant industrial backgrounds or academic backgrounds. We're a global company, as I said, so we don't really have a head office. We have 3 main offices, but we're growing all over the place. We've got, even now in Stockholm, we've got a person here. But we're growing. And we are sort of trying to handle, well, exactly what we show here. End-to-end sensor to predictions. All right, so we're collecting data from the edge. That could be anything from a ship to an oil platform to a wind turbine to a factory. Streaming that data, running models and stuff on that data, allowing you to deploy models. So if you have data scientists or you've had someone to develop models for you, you can deploy it, add it to your streaming data, and then put it into things like dashboards. Everybody loves dashboards. But it doesn't have to go into a dashboard, but you can do that, or you can pump it back into a control system, into a database, into an Excel sheet if you're a nightmare or a manager, whatever you desire. So here's some examples of where the Edge Agent in Arundo has been installed. Now, the Edge Agent is my kind of baby. As you've seen a bit from my background, this is what I love. I love connecting devices. I love connecting control systems. So here's just some examples of where we've got this sitting today. One's a factory in China for spinning thread, and one is a tugboat in the middle of the Swedish Sea. Now, for the management folk right there, this is maybe a little bit too dirty. Let's look at the fancier slides. We've got the minority report type dashboard, and we've got the nice big slide that you saw earlier from Jake. But these are actually, this dashboard is something we actually made, and what we were told to do was make it look like Minority Report, which is the exact thing that we were told to do. But the technology behind this is pretty cool. We're streaming all this data from these factories in China, top right, and running it in through models. It's things like KPI models. It can be things like predictive maintenance, so determining if there's going to be a failure, and pumping it into these sort of dashboards that can be viewed by operators or by sort of management in maybe even a different country. So then that really brings me on. It covers a bit about what we do with Edge. So we have Edge Analytics. We collect data. We can deploy models back to the Edge. But this is where it brings in the next sort of big problem, because a lot of people are sort of doing this today. As sort of was mentioned in the previous talk, a lot of people are collecting data. It is something that a lot of people have a handle on data. But what we've come across a lot recently is this thing, this data lineage. And according to Dataversity, who claim to know a thing or two about this, they say data lineage describes data origins, movements, characteristics, and quality of data. So if you're someone that you're subscribing to a data stream, do you really know where that's coming from? Do you really know if that's the raw data, if it's been aggregated, and lots of these other things? So this sounds like quite a new thing. And it is in the IoT space, but think about just an everyday occurrence that might happen. Let's say a US tourist is visiting Norway. They've rented a car, and they've had an accident with that car. It may look something like this. All right? So they've had that accident. They have to make a claim when they get home. Maybe it's an injury claim or whatever it may be, but they have to make a claim to their insurance company. This is how that workflow might look. This is what they're bringing their insurance company, this nice car accident report. But how does that car insurance company know it's not just something they've written on the plane on the way home? So if we look at the flow of how this works, a police station in Norway, they write a report, they create an official stamp, or they do something official on it that makes it clear that it's them that's done it. But it's in Norwegian, so it has to go to an official translator. Then all the prices and stuff are in Norwegian kroner, so it needs to be officially converted to US dollars. And maybe there's a geolocation service or something used as well to all come together and build up this report. Now, the insurance company can see via whatever ways they do that this is an official report because it has the correct stamps. It's been passed through the proper channels. It's done the correct translation by someone that they know is not just, a teenager sitting in the basement. And that will come to a report that's trusted. This is what we're trying to achieve with sort of in the IoT space as well, that when you as a subscriber to data, which could be this, can fully trust all the areas it's come from, all the decisions that's been made in that data, and how you can actually easily see where that data has sort of mutated along the way, potentially. So let's look at a real-world example that we work with in Arundo. Here you have these, a big shipping container, but these beautiful little things here, it's a bit of a David and Goliath. These things called tugboats. These are really cool. Their sole job is to make sure that if this big container starts to veer off course or something, lose control as it's coming into port, that they can pull it back on or stop it. These tiny little things can control this massive big boat. So we work with some tugboats. And what we do is we stream that data from the tugboat using an edge agent into Fabric, which is our cloud environment. Now, because it's an Arundo to an Arundo product as such there, that we can assume that it's trusted. We can say, well, we kind of know our own stuff, and we do security in certain ways. So we can assume that. But what happens if that data wasn't coming from an Arundo edge agent, for example? What happens if we have a model deployed on the edge agent? Maybe this tugboat has a very, very poor bandwidth. So they want to stream 500 signals or 500 tags, but only, or not stream, but they want to run a model based on those 500 tags and only stream the output of that model. So already that output has gone through some sort of mutation. So how do we know that when we are someone later on subscribing to that? But let's just say the edge agent is sending raw data to Fabric. What we also do with this customer is we stream it to Veracity. I don't know if has anyone here heard of Veracity? Yeah, so we've got some DNVGL, the sort of world's governing authority for shipping and so on. They have this open data platform called Veracity, where you can share your data and you can buy services and stuff on top of your data. So this particular customer wants the data to stream from Edge Agent into the Arundo Fabric, run some models in Fabric, and then also send the data to Veracity so they can share it and stuff later on. So you think of all the transformations this data might have gone through, from Edge into Fabric. Maybe there's a cleanse or something done. Maybe there's an aggregation done, and then into Veracity. This is the sort of thing that we start to see people struggling with. It's not just a case of getting access to a data stream. You need to now start to know where this is coming from. So I think this is an easy example of this. And to really show you that very rarely do we just read a raw sensor, raw piece of data, and act on it. So here you have a room temperature that goes into a report. That report is fed into some machine learning algorithm, which also takes a few other sensors that have ran through a cleanser that then generate a report 2. You imagine being the person down here in report 3. Whether it's due to governance, maybe in your company you need to, through governance, show where decisions are made or why decisions are made, or maybe it's just for doing things like optimizing those decisions later on. How do you know today, if this is an Excel sheet, how do you know all of the decisions that's been taken through machine learning algorithms and so on? How's those assumptions been kind of come to? So this is what we're trying to solve. So then, you know what we do with technology. When we start to talk about problems, we like to throw some buzzwords into the mix. We'd like to talk about Industry 4.0. We like to talk about blockchain. We like to talk about whatever else, digital twins and digital triplets and the rest of it. So blockchain. Well, we all know, or a lot of us know, the sort of pros and cons to blockchain. And it's something that's talked about a lot today. It's a bit of a scary technology for a lot of people. But really what it is, it's a very good data ledger technology, right? What it does very well is it traces transactions very, very well. So what we sort of thought we could do was use that part of blockchain technology, actually the thing that stores and tracks a transaction, and hopefully use it to show how decisions are made on top of data. The nice thing is, we're not the only ones thinking about this. Has anyone in here heard of IOTA? Yeah, cool. A few people have heard about IOTA. So IOTA is sort of taking the best parts of the sort of blockchain technology, but trying to shape it and fit it for the industrial Internet of Things, or the Internet of Things in general. So trying to remove some of the latency and the sort of speed problems you have in blockchain, some of the huge energy costs and stuff you have. And they're doing a very good job. They've even signed partnerships with people like VW recently to try and make things like the new e-passport, they're calling it, for your car. So in the future, when you buy a car, you'll just get a digital booklet that has a trace of all the services done on it, any accidents. It's been in like a full ledger for what that happened to that car since day one. So we're working with, for example, DNV GL to try and build this data lineage model using IOTA. And to really get there, the first thing we have to solve is the data integrity. So how you can prove where data is coming from, how you can show that it's a trustworthy source, it's not been tampered with along the way. Then show that transparency on top of it. It's just the case of showing, is it the raw data? Has it been manipulated at any point? Right up to then, once you've got there, you've got that trust. So we think back to the insurance report right at the start. You know, once you see that it's got everything checked off, then you trust it. And that's what we really want to get to here. So if we take a look at this, back to the same example, but at the top I've got this thing at the top. This is called the IOTA Tangle. It's a decentralized system, but you can think of it today as like just a service, right? Just like a Google or a central service. And what we can do, if we're sending data from the edge to Fabric, we can authenticate it some way. We can make a hash. We can do something like that, where we send that then, we send the data, and then we store the hash in the IOTA Tangle. Now, as I said, this is a big decentralized system. So anyone subscribing to that data from the edge agent can get it. And they can say, oh, I've got this hash from Arundo. I want to check that nobody's tampered with it along the way. So they can go on to the IOTA Tangle, and they can query that hash and see that it's correct. And if it's not correct, someone has tampered with it along the way. The same, every time this data goes through a transformation, you can send this new hash into the IOTA Tangle. The really smart thing about IOTA and how it works, and we don't really have time to touch on it today, but it uses a thing called a Myrtle tree. So anyone that's sort of done computer science or sort of mathematics and stuff will know what that is. And the nice thing is, if you have a root address, it will always see all the transformation, all the children of that root, all the way through. So if you're someone who's maybe subscribing to data from Veracity, it might be 6, 7, 8, 10 children below the sort of master data. And with the technology behind IOTA, you'll be able to track that, which I hope to show you if we have time. Yeah, we're good. So this is what we're trying to achieve. We're wanting to achieve that, yeah, you might be the person that's just subscribing to the data here. It's never changed. It just maybe went through different servers and what have you. But you might be someone here. So the data's went to a different provider. Maybe some analytics and stuff has happened on it. Went to a different provider, and you've ended up here. So it's maybe changed multiple times. But you want to make sure the thing you're getting is still secure. It's still from a trustworthy source. But you can see all the transformations along the way. So let's try and give a quick demo of this in action. So this is when we get, this is when I do the wrong thing. There we go. Okay, so I'm just created here. There's two command lines. One is a writer, which writes a message that I've got. So this could be anything. This could be a piece of data that I have that I'm sending to Fabric, say from an edge agent. And the other is a reader. Okay, so I'm going to say, hello, guys. All right, now sometimes depending on your network connection, I am still doing this in a test environment, and it, as of course it does now in a demo, it takes a bit of time. But normally it returns me this root address. There we go. Okay, so finally I've got this sort of root key. So this is my key within the IOTA tangle. And the really nice thing is, as long as I know this, I can always, if I put this into the reader, which is the thing that's listening for this data, I can always track now what's happening with that. So we will see eventually a pop-up saying, hello guys. There we go. It's in a JSON format, so I apologize if it's a little bit not the clearest to read. And then I'm going to do hello girls. So I've taken this data now, and I've manipulated it, I've changed it. I've changed it from hello guys to hello girls. So it puts it back on, so it's taking this, it's creating a hash, and it's putting in the IOTA tangle. And actually I've decided, oh, hold on, there's a few too many guys in the room as well. So I'm going to change the data one more time and say hello everyone. Okay? And it will send it and put it in the IOTA tangle. So already just that data's changed 3 times. Now this is simple. This is just a small message. This isn't like a complex thing, but it's same sort of principles for something more complex. What I'm going to do is I'm going to go over this very simple web app, which just sort of monitors the IOTA tangle. And I'm going to put in that message. And if it works, which of course it's a demo, so it's not working, let me just refresh. Give me a second. It is important to note that IOTA is still in a bit of a beta phase, so sometimes when you query their systems that we don't get a return. So I sort of envisioned this happening because it might have happened once before. So ta-da! This is what you would get. So I'm sorry I couldn't show you that. But typically what you'd see here then is you will see the transformations the data's went through. Hello. And we would have seen hello guys, hello girls, hello everyone. Just because we know that root address. So the idea is here that I have full traceability of the transformations this data's went through. But at the same time, I can easily see sort of who it's come from, the different layers it's been through, and so on and so forth. And then basically, if we get to that stage, we have our data integrity, because when one thing receives a piece of data, they can confirm that it's from who it's been sent by. We have the transparency. So then we automatically have that trust, and we all look a bit like this. All right, and I think for data scientists and stuff today, and this is a big issue because it's really understanding where the sort of master data is, the transformations, and then for like things like managers and so on that are really a bit worried today about automation, making decisions based on models. This is a really easy way to sort of see how those decisions are made later on, and when they were made, by who, and so on and so forth. So it's a lot to cram in, and as I said, there's sort of a. It's really. I hope some of you ask questions and stuff later, but there's a lot to cram in. So I added some further reading. As I said, we are collaborating with DNVGL on this. So there's a fantastic blog post by one of their architects, and I stole some of his diagrams in here. I recommend you read, because he talks in much more detail about the actual technology behind this and how you can query it and so on. And if you've never heard of IOTA, I suggest reading their illustrated introduction to IOTA, because things with blockchain technology and stuff can be a little bit hard to get your head around at first. And then in more detail around IOTA, this masked authenticated messaging, which is what we're using to give this data ledger. So those slides are shared, so you will get them.
You will receive them tomorrow.
You'll receive them tomorrow, there we go.